Now, considering the problem, show that the maximum value of x plus 1 by x is less than its minimum value, and the solution is first consider let fx is equal to, or you can take as y, fx is equal to x plus 1 by x. Now derivative with respect to x, so the dx of fx we can write it as f dash x is equal to derivative of x is 1 and derivative of 1 by x is minus 1 by x square. Now for maximum or minimum value of fx, we have f dash x is equal to 0. For maximum and minimum value of f, we have to put f dash x is equal to 0. That is, here f dash x is 1 minus 1 by x square. This is, so this equal to 0, which implies x square minus 1 is equal to 0, which implies x is equal to plus minus 1. Again we have to calculate f double dash x, that is, from this f dash x is 1 minus 1 by x square from this, which implies f double dash x, that is second order derivative of fx, that is equal to 0 minus 2 by x cube, minus minus a positive, that is 2 by x cube, derivative of 1 by x square minus 2 by x cube, so this is positive, so f double dash x is 2 by x cube. Now for again 2 by x cube, now for 2 by x cube at f double dash 1 we can consider, and maximum minimum value is fx, x is equal to, now f double dash at x is equal to 1, f double dash 1 is equal to 2 by 1 cube, that is equal to 2, that is greater than 0. So we can write fx is minimum, as it is greater than 0, fx is minimum at x is equal to 1 and its minimum value is m value is f of 1, m value is f of 1 is equal to 1 plus 1, that is 2, that is x in place of x plus 1 by, at f of x is equal to x plus 1 by x, so this is fx is equal to x plus 1 by x, putting 1 in place of 1, f of 1, so 1 plus 1 by 1, that is 1 plus 1 is equal to 2. So minimum value at x is equal to 1 is 2. Now Now at x is equal to minus 1, we have f double dash 1 is equal to f double dash 1 is equal to f double dash x is 2 by x cube from this. So here minus 1, f minus 1 is equal to 2 by minus 1 cube, that is equal to minus 2. So f double dash minus 1 is minus 2. So this is less than 0. Hence fx is maximum at x is equal to minus 1 and its maximum value and its maximum value is f of minus 1 is equal to, in place of fx is equal to x plus 1 by x. So from minus 1 is minus 1 plus of 1 by minus 1, that is equal to minus 1 plus 1 by minus 1. So minus 1 minus of minus 1. So minus 1 minus 2. Now so we can say that the maximum value is maximum, so we can say that the maximum value is less than the minimum minimum value. Again we repeat the problem discussing. The problem is, show that the maximum value of x plus 1 by x is less than its minimum value. Here we consider fx is equal to x plus 1 by x. Now first order derivative with respect to ddx of fx, we can write it as f dash x. This is called first order derivative of fx. This equal to ddx of x is 1 and ddx of 1 by x is minus of 1 by x square. Now for maximum and minimum value of fx, we have f dash x is equal to 0. For maximum and minimum value of fx, we have to put f dash x is equal to 0. So here f dash x is 1 minus 1 by x square is equal to 0. So this is x square minus 1, so x is equal to plus minus 1. Now for f dash x, now from f dash x is equal to 1 by x square, this gives f double dash x, that is second order derivative of x, that is again derivative of fx. F double dash x is equal to derivative of 1 is 0 and derivative of minus 1 by derivative of 1 by x square minus 2 by x cube, and minus minus is positive. So f double dash is x is equal to 2 by x cube. Now for value f again f double dash 1, that is f double dash x is 2 by x cube. So in place of x writing 1, this one. So f double dash 1 is equal to 2 by 1 cube, that is equal to 2 greater than 0. So fx is minimum at x is equal to 1. Since it is greater than 0, so fx attains its minimum value at x is equal to 1. And its minimum value is f of 1 is equal to 1 plus 1, as fx is equal to x plus 1 by x. In place of 1, f of 1, so 1 plus 1 is 2. So 1 plus 1 is 2. Now at x is equal to minus 1, now for another value, first consider 1 and then consider minus 1. At x is equal to minus 1, we have f double dash minus 1, that is f double dash minus 1 is equal to 2 by minus 1 whole cube, that is equal to minus 2. This is minus 2 is less than 0. So fx is, that is, hence fx is maximum at x is equal to 1. Here since less than 0, so fx attains its maximum value at x is equal to minus 1, and its maximum value is f of minus 1, as fx is equal to x plus 1 by x. So f of minus 1 is equal to minus 1 plus 1 by minus 1, so minus 1 minus 1 minus 2. So from this result we have see that minimum value is greater than its maximum value. So we can write from this, the maximum value is less than its minimum value. Maximum value less than its minimum value. So the problem solution is complete. Please like, subscribe and share.